in the A&D industry, with roles at the U.S. government, Lockheed Martin, PTC, and Jama Software. She is a member of the NCOSI and member of the Women in Aerospace organization. Outside of work, she enjoys playing jazz, guitar, and gardening around her farm, which sometimes requires the operation of tractors and UAVs. And with that, I'll pass it over to you, Cary.
Thanks, Juliet, for your really kind introduction. Just wanted to give a little bit of an introduction. What we're seeing today is just an unprecedented level of digital interconnectivity in seemingly every system out there. The aviation industry has a high degree of cyber connectedness where a negative impact could really cause harm to not just humans and property, but company reputations, international relations, or financial systems. What we're going to see today is how Jama Connect can provide a cybersecure-by-design approach to meeting the many aspects of DO-326 and DO-356, or ED-202 and ED-203 in EMEA. What we're going to see is we're going to apply the airworthiness security process that's inside of DO-326 and use Jama's live traceability to trace security measures to security requirements, trace security requirements to testing, look and see how the threat analysis can all be incorporated into a single platform. What is cybersecurity by design? So one of the things that we see a lot is in the tool ecosystem is a very disconnected set of processes and tools. So whether you're tracing and using tools that do requirements identification, tracing those to verifications and hardware and software designs, or whether you're using tools to do aircraft security analyses and tracing those to security architectures and security V&V, we're noticing that the disconnectedness of the processes in the tool ecosystem is causing product delays, cost overruns, product failures, audit failures, late identifications of defects, and lack of visibility because the ecosystem is very disconnected is taking place. There's poor requirement coordination. Change management is hard between software and hardware. And you have a high degree of manual effort required to produce the traceability that's required for certification, and you're seeing this sort of after the fact. And Excel is used everywhere. Desktop tools are prevalent in these engineering for these systems, and it's difficult to integrate desktop tools and Excel files sort of into and across the ecosystem for product development. So what is live traceability? Live traceability in Jama gives the ability of any engineer at any time to see the most up-to-date upstream and downstream information for any requirement, no matter the stage of the system's development or however many siloed tools it spans. Now, this live traceability is important because it's required by the industry standards, like we see in aviation development. And live traceability delivers a huge productivity improvement, and it reduces the risk and the delay that happens when you have a disconnected sort of tool environment. So we're going to talk about DO-326. DO-326 is really a set of standards jointly developed by RTCA and EuroCAE. It came about in 2006. It actually includes a few separate standards. DO-326 and ED-202 really is about the airworthiness security process specification. It explains sort of the fundamental concepts behind airworthiness cybersecurity. DO-356 and ED-203, the airworthiness security methods and considerations. This explains how to perform cybersecurity investments, how to evaluate threats, security measures of the system, how do you apply the mitigation measures? DO-355, we're not going to really talk about that one today, but it's applicable to if there are changes in an already certified system. So one of the most relevant documents you're going to start with, even before you start down the path for cybersecurity, is creating your product information and security risk assessment document. You're going to perform an analysis of this, and this analysis should be conducted according to the standards, right? So what exactly is airworthiness? So airworthiness security is the protection of the airworthiness of the aircraft from intentional unauthorized electronic interaction. So existing safety processes don't consider intentional disruption. They look at the faults and failures of an aircraft or the aircraft system on a whole, but DO-326 is specifically looking at intentional human-initiated actions with the potential to affect the aircraft due to some kind of unauthorized access or disclosure, or causing some kind of denial or disruption of the information systems, the networks and the software that's running on these aircraft systems. So this also might include things like malware or infected devices, or the logical effects of any kind of external systems. So the purpose of the airworthiness security process within DO-326 is to establish that when subjected to this unauthorized interaction, the aircraft is going to remain in a condition for safe operation, right? So like I said earlier, DO-326 describes the what, and DO-356 is the how. I'm sure that you guys have carefully looked at both of these guidelines, and these are images from the guideline, but I just wanted to point out kind of what we're going to talk about today. We're going to talk about how the airworthiness security process and threats are mapped in JAMA, and how you can have security assurance and the risk assessment process from DO-356, how those can be conducted in JAMA itself. As you know, the DO-326 doesn't live in its own. You're having supporting processes from the development of the aircraft, the development of the system. DO-178, ARP 4754 are all interacting and being conducted at the same time. So there's no linear, do this first, do this next, do this later. All of these processes are taking place pretty much simultaneously or iteratively as you design and develop the aircraft system. So the airworthiness security process, from a basic level, it's again, it's the protection of airworthiness of the aircraft from intentional unauthorized electronic interaction. There's 4 steps for the basic process. We're going to first identify the system assets and its perimeters. The second step is to identify the threats for all of those assets, identify those risks for each of the threats, so what might happen, and then create controls and mitigations for those risks. There are, you're going to be adjudicating sort of the degree of harm and assigning a security assurance level, the strongest being SAL 3, or the least would be a SAL 0, where there's this limited or protection needs required. So there's a way to grade those as well. The inside of JAMA itself, this image describes essentially the architecture of what you're going to see, that what we have in the product. We have a template that you can use to facilitate this. It sits alongside of our template that's used for ARP 4754 and DO-178 or DO-254. The orange assets essentially is the data model that we're using to capture the different types of things in the system. So we have assets, we have vulnerabilities. Those are tied to different threat assessments, or a threat assessment is performed on these types of objects. We have security measures. We have the security architecture elements, and those feed into the security requirements. This comes pre-configured out of the box. We also have an area where you can capture the data for that kind of thing. Having this sort of a data model enables engineers to really perform the analysis to understand, all right, which assets have I not assessed yet? What's the workflow? Who has reviewed the threat assessment? Have the security measures been satisfied by security requirements? Have those been, have we done security testing of the system? So this sort of data model enables the traceability to be instantiated and allows engineers to really more easily create the kind of a content. So one of the benefits you see of using Jama is that the security process is not disconnected from the design and development of the aircraft system itself. It's done alongside, so that way you have that earlier touch points between the functional aircraft design engineers and the security engineers. So you're building in that secure by design approach. So essentially what we're going to see, it starts with your plan for security aspects of certification. You're going to identify what are the assets of the aircraft that have cyber boundaries. You know, one of the things that you do in the PSEC AC is identify that security scope and the boundaries. That'll enable you to identify those assets. For each of those assets, you're going to